say we have something in this form right here. Okay? In other words, over here we're looking at some sort of polynomial with a square in it. Okay? But we have it set equal to 0. Well, what does that mean? Well, that means that whenever you do out the math here, your end result is going to be a 0 over here. Okay. So what I can do is I can look at this as if this were a y here, or say an f of x. Okay. Right. So y equals now a quadratic. Okay. This is going to give us a parabola. Let's say we were to graph that parabola. Say it ends up looking like that. Here's my vertex. Okay, now there's a couple of important events here. Here's where I cross the y-axis, okay, y-intercept. And now I want to talk about the x-intercept. Okay, the x-intercepts. Alright, these are the x-intercepts. Well, what happens when I'm finding the x-intercepts? Okay, what's my y value? Right here. My y is a 0. Okay? So if I have something in this form, okay, I'm essentially finding the intercepts of a quadratic. Okay? At least, sorry, the x-intercepts of a quadratic, when that y is equal to 0. Now it's possible, depending on our quadratic, or depending on our equation what we have, that maybe we're not going to ever cross the x-axis, right? There's nothing saying that we always have to cross the x-axis. Now at some point we're always going to cross the y-axis one time, okay, right? In order to be a function, you can only cross it once, right? But we don't have to cross the x-axis. Okay, so it's possible we could cross the x-axis twice. It's possible we may never cross it. It's also possible that we're going to cross it once. Okay? If the vertex is touching the x-axis, then it's only crossing the x-axis one time. So when we have a quadratic like this, and we start applying our tools to it, it's possible we're going to come up with one solution, no solutions, or two solutions.